All right, Algebra 2. This is going to be a pretty good-sized video here for Chapter 3, Part 2, Game Plan the Matrix. I'm going to give you a bunch of answers here, especially if we don't need to use the graphing calculator matrix application form. This game plan is going to be due for you on Thursday, 12/3. And if I explain it in the video, not going to talk about it in class. So we definitely need to watch this video Friday, Monday, or Tuesday. It's going to be due 12/3. All right. So just honestly going to start from the bottom or the first page here. Now we should have these again. Dimensions of a matrix are row by column. 2 rows. Rows go horizontally. Columns go vertically. If you forget, think about a column of a house. It definitely goes vertically. Can add or subtract matrices if they have the same dimension, so I just correspond. -7 goes with 6, 3 goes with a -9, and 8 goes with -11. Can't add 6, cannot add. They do not have the same dimensions. A 1 by 3 and a 1 by 2 won't add. On 8, I just multiply all of those numbers, elements, by a 4. And on 10, I multiplied everything here by -4, everything there by 6, and then I added the two matrices together. Again, what I'm doing, -28 plus 48, that's how I get 20. That is page 1. Page 2, give a lot of answers here. Now I'm going to change this to 16. Make that 15 into a 16. You're multiplying every number in here by a -3/4. Multiply everything number in here by a +2/3. I think Algebra 2, we need this. And then add the matrices up together. Again, pause this whenever you need to. We're going to try to make this video a little bit on the quick end. So pause it if you need to. Multiply everything by 6, everything by 3, everything by 4, +4, so you can just still subtract them. 42 plus a -12 is 30. 30 minus 4, that's how we get 26. And this is a -11 there. All right, on 13, think about those order of operations. I need to add the two matrices, in here together first, and then I multiply everything by -6. If I make an arithmetic error, just don't copy it down. Write the correct one. I went through this very quickly. Multiply everything here by -7, then everything here by an 8, and then combine them. All right, so on 15 and 20, given the 4 matrices, 2 are 2 by 2, 2 of them are 2 by 3. What's 4a plus 2b? Well, there's 4a, 4 times everything in a. There's 2 times everything in b. Combine them. On 17, here's -3 times b. There you go. 19, I wrote b, then I wrote a. Subtract them. 20, if you take d and double it, then subtract c. There we go. Okay, just doing arithmetic now. We did this Thursday in class. You can multiply matrices if the following happens. So the number of columns here equals the number of rows there. If those two inner numbers are equal, then we're good. So yes, you can multiply them together, and the dimensions would be a 3 by 2. So 2 not defined because 3 does not equal 5. Can't do it. Can add and subtract them, can't multiply. 6 equals 6, so yes, matrix AB has a product. A times B will give you an answer. Matrix AB will be a 4 by 3, those outer numbers. 4, yes, AB can happen. 3 equals 3, and matrix AB will be a 2 by 1. 5, yes. The only time you can multiply two matrices with the same dimensions are if they're both square matrices. 2 by 2, 3 by 3, 4 by 4. 2 equals 2, so matrix A is going to be a 2 by 2 matrix. Matrix AB is a 2 by 2 as well. And then finally, 3 by 1 and a 1 by 3. 1 equals 1, so yes, AB is going to be a 3 by 3. Now, you can use your calculator here on 7 and 8, but here's how you do it by hand. Just like dimensions are row and by column, you multiply the first row by the first column. That's how you get your first row, first column answer. Now, you have a 1 by 3 and a 3 by 1, so yes, you can multiply, and your answer is going to be a 1 by 2. 1 by 2 looks like that. So what you do is you do 4 times a -2 plus -7 times a -1 plus 3 times 0. And that sum there Okay, well, I thought it was like a 17. No, wait, that's sum there, which is a -1 is your first row, first column. Then you have the first row, which is the only row, times the second column. 4 times 1 plus -7 times 3 plus 3 times 4. So I showed Honors Algebra 2 how to do it by hand. You guys could use your calculator, which we'll talk about on Monday the 30th. You can use your calculator. Everybody fill this in. Does AB equal BA? So is matrix multiplication commutative like, regular multiplication? All right, we got 8 times 7 is 7 times 8. So 8 times B, I wrote A and I wrote B, and I did the same thing. Okay, a -7 times -1 plus 3, or 2 times 3. That's how I get... Yep, the 13. So 8 times B is that, and again, you can use your calculator. So somebody in class use their calculator to answer that. B times A does not give you the same matrix, so it's no, matrix multiplication is not commutative. Then honestly, we use the calculator for this. Here's an answer for 11. Then here's an answer. Again, this can happen in 2 by 4, 4 by 2. Those inner 4s equal, so your answer is a 2 by 2. Again, if I made a mistake, I try to do this in my head. If I made a mistake, let me know. All right, so this next page, 5, is just a review. So can you multiply? Again, look at those inner numbers, yes or no. So this should make sense. And if you can find the product, what are the dimensions? 3 is not defined. 2, 4, and 6 can happen. Number 4, that's just a single number, 1 by 1. Done is 4. Honors Algebra 2, who has already turned this game plan in. So find the products. So you only have one row and you only have one column. 6 times 2, you only have one row and one column there. So first row, first column. First row, second column. Second row, first column. Second row, second column. You're doing a 2 by 1 and a 1 by 2, so your answer is going to be that 2 by 2 matrix. And again, you can use your calculator here. Number 9, you have a 2 by 3 and a 3 by 1. You're going to be left with a 2 by 1, which is something that looks like this, and that is your answer. We are a-rolling. All right, determinants, difference of the cross products. I think Algebra 2, you have this answer. You should honestly do a 2 by 2 by hand. It's not that big of a deal. 8 times 7, which is in blue, minus -4 times 2. A determinant is a single number. There's number 2, -6 times -9, minus -7 times 8. There's a very special determinant. Again, we should have these answers already. Determinant of 0, that's very important. Tells you something about the inverse of a matrix. Very special answer. There's number 5. What we don't have is this last one, which is a question that counts. You can definitely use your calculator for 3 by 3. What you do is you rewrite the first 2 columns, rewrite them, and it's still a difference of a cross product. So you do that cross. Up here we did top left to bottom right minus top right to bottom left, and we're doing the same thing here. So the top left, bottom right are these 3 cross products in blue, and then you subtract the 3 cross products in black here. Then all of these numbers in here are being utilized. You might be like, Mr. Jack, that 0 here is not circled, but it is there. That -2 is not circled. Yes, it is right there. So you do 2 times -2 times 5 plus -1 times 1 times -3 plus 3 times 0 times 4 minus some of these cross products, -3 times -2 times 3, and so forth. All right. Again, pause this whenever you need to. You get -43. Again, your calculator can handle that. Monday the 30th, Tuesday the 1st, we'll talk about that. This is also what we did on third. Well, we didn't do this top part. So here's an inverse matrix. If A is equal to the matrix A, B, C, D, then A inverse is 1 over the determinant of A, hence why we just found determinants, times this interesting flipped matrix. Notice how A and D switch positions and B and C take on the opposite values. That is A inverse. So find A inverse by hand. Again, you can use your calculator. Well, the determinant of A is just 1. So A inverse is 1 over 1, and then 1 and 3 flip positions. -1 and -2 are now both positive. So A inverse is that pleasant matrix there. Most of the time, you're going to get fractions. So the determinant of X is 15. So X inverse is 1 over the determinant, which is 15. 3 and 4 switch positions. -1 is positive. 3 becomes negative. Multiply everything in there by 1 over 15. So if matrix A times matrix X is equal to matrix B, then matrix X is equal to A inverse B. That's how we can solve these terrible systems on the next page. But 3 and 4, honestly, just do it by hand. This was from the last chapter, which we did a pretty good job of. I was just using elimination here, make the X's match up. All right. Honestly, just do that one by hand. Number 4. Also, just do that one by hand. I'm getting rid of the x's again. Multiply top equation by 3, bottom one by 5, adding the equations up. So first one I subtracted, here I added. Get pleasant answers. Next page, though, is all about x equals a inverse b. You really need the graphing calculator for that. Here's how we set up number 7. Matrix A, all the coefficients, 2x, 3y, negative 4z, 4x, negative 1y, 5z, 3x, 2y, 4z. My constants then, which is matrix B, 20, 13, 15, again, equals, make sure it's on the other side of the equals sign. Matrix X is what I'm searching for, X, Y, and Z. So X is A inverse B. That went to our calculator, and we got pleasant answers. Just be careful on number 9. You have some zeros in there for matrix A. All right. So page 9, very easy as well. Right, each has an augmented matrix. We've already probably talked about that. 2, 1, 1, dot, dot, dots, equals 1. Now I had to switch it. That's 2y and 3z. Again, this is something that we have chatted about in both classes. So this should be review. There's for 2. This time we don't have 2 separate matrices. We just put it all together in one matrix. And here's number 6. Given the augmented matrix, what's the system? Do not solve it. Do not solve it. Folks, we are a-going here. Number 10, we might have done this, but I made a typo. It should be 2 4x2s. And honestly, the first, so this is a matrix, all right? The first one, there it is. Male and female verbal scores. The second matrix, male and female math scores. And to find the combined scores, you just add the verbal and the math. All right, 507 plus 533, 504 plus 498, and so forth. Very easy question. Sorry. Find the sum. Just add them up. -7 plus -3 is a -10. All the way down to -4 plus 11 is 7. On B, -10 plus -4 is -14. All the way down to 9 plus 2 is 11. Okay, the bottom is just a fact, the zero matrix. It's got nothing but zeros. And that's what we want to get, the zero matrix on 2, A and B. The additive inverse are just the opposite of all those elements. -2, -8, 3, and 0. And then here, the opposite of all those elements. Get all these done and finish whenever. That was for Honors Algebra 2. Who should not be watching that because your game plan's done. Find the difference of the two matrices. -2 minus a -4. 6 minus 2, -3 minus 3. 8 minus a -5. Same thing here. Do 5 minus a -3 all the way down to 7 minus 3. Correspond them. All right, number 4. Find the value of x. Just subtract, not that. That 4. So x plus 8 would correspond to 38. So set x plus 8 equal to 38. -y is equal to 4y minus 10. Solve for x and y. I got to do 3x equals -9 first. Then I can plug -3 in for x to figure out what y is, because x plus y equals 4. Now here on 5, again, this whole page, I'm not going to talk about because it's in the video here, and it's not too bad. You got matrix x plus that 2 by 2 is equal to the other 2 by 2. So I need to subtract that matrix, which is -1, 0, 2, 5 from the other side. And then I get matrix x is 11, 7, -6, -1. Okay, this is definitely with your calculator. That's matrix A, that's matrix B. You need x equals A inverse B. This is another one to do when we get back. You need to write matrix A, 0, 9, 2, 3, 2, 1, 1, -1, 0. Matrix X equals matrix B. X is A inverse B. Your answer will be a 3 by 1 matrix. Okay, we're going to skip to this page. Almost done here. Given the augmented matrix, write the system. Given the system, write the augmented matrix. And number 6, add them up. And number 8, double the first one, minus, triple the third one, and then combine, like, and then just, -2 minus the -3 is 1. 1 plus a -5, 6 is a -5. I'm done there. Too many mistakes. All right. You can pause this when you need to. Number 9 and 10, find the determinant. Again, a 2 by 2 is easy. Difference of the cross products. It would take too much time to type it in and let your calculator do it. -3 times 8 minus 5 times a -4. It's just a single number. Easy peasy. On 10, 3 times a -1 minus 2 times 5. Find A inverse, but we don't have to do much here because if you get a determinant of 0, you have no inverse. Because A inverse is 1 over the determinant. Right away, that is undefined. So it doesn't matter what you're multiplying by. Something multiplied by undefined is going to be undefined, no inverse. Use your calculator for 12 through 14. We're going to move on here. 10z plus 12 is equal to 38. 3x minus 1 plus a -4x plus 5 is equal to 35. All right. I think there was a video made for Honors Algebra 2, so you might want to check that out. Regular Algebra 2 as well. This one obviously is the best video for you to watch first. Given the augmented matrix, write the system. There it is. Whereas number 4, given the system, write the augmented matrix. A bunch of zeros there. 6, just correspond each element. 7 minus the -8 is 15 plus 3 is 18. Keep going. So again, you can do these by hand. It's no big deal. It's arithmetic. So I multiplied everything in this matrix by 4, plus multiplied everything in that matrix by 3. 20 plus 15, 35. That's the answer. And here we go, folks. -4 times a -1 minus 5 times a -2. 2 times 10 minus 5 times 1 is 15. All right, so that is your big video for this matrix game plan, which I will check that first week back. This is Yak Math Video signing out.